Hello everyone, welcome back again to our summary video of chapter number 9, that is Algebraic Expressions and Identities. Let us start the summary video. First we will check the mind map of the chapter. In this chapter we have learned first the definitions of algebraic equations, then we have identified from the algebraic equations the term like constant, coefficient, variable and factors. After that we have learned the like and unlike terms. Next we have learned the types of expressions like monomial, binomial and polynomial. Next we have learned how to do the operations such as additions, subtractions and multiplications for algebraic equations. Last we have learned in this chapter, that is the identities. Means first we learn the identities, then we learn how to apply the identities for the problem. First, the definitions of algebraic expression. So the definitions is, it is an expressions that is made up of variable and constant along with algebraic operations like additions, subtractions, multiplications, divisions, etc. Expressions are made up of terms. So examples of expressions are 5x plus 20y. This is a algebraic expressions where 5 and x related with the multiplication sign. Similarly 20 and y also related with the multiplication sign, and 5x and 20y related with each other with the addition sign. One more examples we are taking as 6 minus 8x. In this example, we will find out which one coefficient, which one constant, which one variable and which one the factors. Let's check that. So 6 minus 8x. 6 is the constant part of this algebraic expression, and x which are varying, means which can take different value for the algebraic expressions, that called variable here. And with the variable, which number is related with the multiplication sign, that is minus 8, it is a coefficient of the algebraic expression. Next, factors. Factors means 8 and x related with each other with the multiplication sign, and 8 and x are the factors of each other. Now the 6 minus 8x, this full algebraic expressions we call term. Depend on the term of the algebraic expressions, we can classify it in a 3 types. First is monomial, means in the algebraic expressions there should be only one term, that's called monomial. Next, binomial, means in the algebraic expressions there should be only 2 terms. Next, polynomial, means in the algebraic expressions there should be more than 2 terms. It can be 3, 5 or n number of terms. This type of algebraic expressions we call polynomial. Next topic is like and unlike terms. The power of variables and the variables are same refer to the like terms. If it is not like terms, then it should be a unlike terms. Example, 4xy minus 8z cube, 5y square, 4z cube, 2xy and y square. Now 4xy and 2xy are like term. Similarly, minus 8z cube and 4z cube also are like terms. Again 5y squared also are like terms. But if we consider 4xy and 5y square, they are not like terms. That means they are unlike terms. Why? Because 4xy, here the variable x is there. In the 5y square, x is not there. Not only that, check the power of y. Here the power of y is 1 and here it is 2. So the variable is not matching together, even though the power of the variable also not matching together. That's why they are unlike terms. Our next topic is additions and subtractions of the expressions. First, we need to know the steps of additions and subtractions. First step, we have to arrange all the algebraic expressions in row wise and all the like terms one after one. Second step, we have to do the additions and subtractions only for the coefficient of the variable. Third step, the variable along with the exponent of the variable, keep it same as it is. So these three steps we have to follow to do the additions and subtractions for the algebraic expressions. Let's check the example now. For additions, here is the example: 7xy plus 5yz minus 3zx. First expression. Second is 4yz plus 9zx minus 4y. Come to the third expression, minus 3xz plus 5x minus 2xy. This is your third one. Now, as I told you the step, first you need to arrange all the expressions. So first expressions we should write in the first row, second expressions we should write in the second row, and third expressions we should write in the third row. Now, when you are writing row wise, you have to check the like terms and unlike terms. The like terms you need to write one after one, means column wise, and unlike terms should be separate. So check here 7xy, and here in the second expressions there is no xy term. So I keep it blank here. Again in the third expression minus 2xy. So these two terms we wrote in the same column, like that yz in the same column, zx. Here xz is given, but zx and xz are the same term. As we know, the multiplications is a commutative, right? So they are the same variable, and 5x and 4y doesn't have any like terms, so they are separate. Now do the additions. Follow the step number 2. You have to do the additions only between the coefficient, right? So xy and xy, this is likely terms. The coefficient of xy is 7 here minus 2. As we know, 7 minus 2 gives you 5. So 5. 4 and 5, if we add 9. Here minus 3 plus 9 minus 3. So it gives you plus 3. Here nothing is there, so we can consider as a 0. If nothing is there means, so it is plus 5 and minus 4. Now move to the third step of the addition. As I told you, you have to keep the variable along with the exponent of the variable same as it is. We are not going to change anything there, right? So according to that, xy will come xy, yz same, zx, 5x, 4y. So the final answer we are getting 5xy plus 9yz plus 3zx, you can write it xz also, plus 5x minus 4y. Hope all of you understand that. Now move to the subtractions part. The step number 1 will be same as it is like additions, the arranging part. For subtractions, we need to change the sign of the last algebraic expressions. Remember, you need to change the sign only for the last algebraic expressions which we are writing down. So our last algebraic expressions is plus 5x square, nothing is there, means always by default we are taking plus sign. So plus 5x square minus 4y square plus 6y minus 3. We need to change the sign of this expression. So plus becoming minus now, minus change to plus, plus to minus, minus to plus. Why we are doing that? As you know that when we are doing the subtractions, after subtraction sign, whatever the expressions are there, we are going to change the sign of that, right? So this is the reason behind it. Now follow the step number 3, same as like additions. Just do the calculations only for the coefficient, okay? So here you can see the coefficients are 7 and minus 5, not plus 5. So 7 minus 5 means it gives you 2. Here nothing is there, means 0, so it will come same as it is. Here minus 8 plus 4, this gives you plus 12, plus 5x as it is. Then minus 3y minus 6y gives you minus 9y, and minus 3 converted to plus 3. And according to the step number 3, we should not change any variable and exponent of the variable, right? So it will be same as it is. So the final answer we are getting such as 2x square minus 4xy plus 12y square plus 5x minus 9y plus 3. Next topic is multiplications of the algebraic expressions. Additions and subtractions, we have seen that only we can do the additions and subtractions for like terms. We cannot do for unlike terms. But multiplications is little bit different from there. For multiplications, we can do that process for like terms and the unlike terms together. Okay, first listen to the steps of the multiplications. So for multiplications, we need to put the multiplication sign between two algebraic expressions. Then we need to multiply the coefficient together and the variable together. If the variable are same, then we have to add the exponent also. Now check the examples of that. First we will check the examples for monomials. Okay, means as I told you, there will be only one terms in the algebraic expressions. So we are taking two monomials. First one is 5x and second one is minus 3y. And how we are going to multiply? 5x means we can write 5 into x, and minus 3y means minus 3 into y. So 5 and 3, if we multiply together, it gives you plus minus minus, and 5 into 3 gives you 15. And the variable are x and y, which is different, so we cannot add the exponent part. So it will be xy. Now come to the multiplications for binomials. Binomials, here 3a plus 4b, first binomial, then second binomial 2a plus 3b. Now we are going to multiply together, so put the multiplication sign between them. Now first step will be take 1 from the first binomial and multiply to the second binomial's whole. So 3a in the bracket, 2a plus 3b, then take the second term from the first binomial, that is plus 4b, and multiply with the second binomial's whole. So 4b into 2a plus 3b. Now break the bracket. Now what we will do in the next step, we will take 3e and 2e together in the bracket, and next 3e and 3b together in the second bracket. So it will come like, first bracket 3e into 2a, plus sign here it is coming, then 3a into 3b, plus sign here it is coming, then 4b into 2a, means 4b into 2a, plus sign here it is coming, and 4b into 3b in the last term. Now we break it in the monomial, and now we have to multiply all the bracket term. So first bracket, it gives you 2 and 3 together 6, and a both are same variable, so we need to add the exponent, right? Here the exponent is 1 and here also 1. If we add 1 plus 1, we will get 2 in the power. So it gives you 6a square plus it gives you 9ab. Variable are different, so we cannot add the exponent. Same here also, plus 8ba. Last term again the variables are same, so we need to add the exponent, and it gives you 12b square. Now here you can see a, b and be. As I told you, multiplications valid under commutative property. So a, b and ba are same term. So this is same term, means this is a like term, so we can add them through the addition process, right? So it gives you 6a square plus 17ab plus 12b square. Now come to the polynomial. Here I have taken only one polynomial, along with that one monomial. So how we are going to do? We will break the bracket and we will multiply each term with the 3p. So it gives you 3p into 4p square plus 3p into 5p plus 3p into 7. Now it is easy to multiply. 3 into 4, this gives you 12, and because the p and p both are same variable, only the exponent are different, so we can add the exponent and it gives you 12p cube. Next, plus 15p square plus 21p. Hope all of you understand how to do the multiplications for algebraic expression. Our last topic of this chapter is identities. The definitions of identities is the algebraic equations which are valid for all the values of variables. That type of algebraic equations we called algebraic identities. Now we have few standard identities such as a plus b whole square is equal to a square plus 2ab plus b square. A minus b whole square is equal to a square minus 2ab plus b square. And third one is a plus b into a minus b, which gives you a square minus b square. To use these identities, we can solve many problems. Let's check the example of this. First example, that is 2x plus 3y whole square. Can you guess which identity matching with this given problem? Yes, this is the first identity. So here your 2x is equivalent to a and 3y you can take as b, and you can apply the formula here. So what it will come then? 2x whole square, as you know, a square, then 2ab, that means 2 into a, 2x, into b, 3y, plus b square, that means 3y whole square. Okay, now do the calculations for here. 2x whole square gives you 4x square, plus this is gives you plus 12xy, then plus 9y square. So it is very easy to do, right? Now come to another examples of this. 194 into 206. If I ask you to do the multiplications for these two terms, then it will be very big, right? But if we use the third identities, it will come very easy. You can check it. So 194 we can write as 200 minus 6, and 206 we can write as 200 plus 6, right? So here 200 is your A and 6 is your B. So apply the formula directly. So it gives you 200 whole square minus 6 whole square, which gives you that 40,000 minus 36, and the final answer is 39,964. So it becomes very easy, right children? Yes. So practice all the sums properly, all the identities, remember thoroughly, and we will meet again for our next video. Thank you and bye.